Welcome to Lecture 4. Today, we're diving into the exciting world of web scraping, turning websites into your personal data buffet using Python. After this, you'll never scroll a site without wondering, can I scrape this? Before we start writing any code, let's zoom out and understand what web scraping actually is, why it's incredibly useful, and how we'll approach it. Big picture first, code later. Let's kick off with a clear definition, an easy to remember analogy, and the three key ingredients that make web scraping possible. It's not magic, it's just HTML, HTTP, and some Python. Ever tried copying 100 product prices into Excel by hand? Now imagine doing that for 1,000 items, or better yet, having a Python powered robot do it in seconds. That's web scraping! Before we write a single line of code, let's talk motivation. Who actually uses web scraping? Spoiler, probably more people than you think. From indie hackers to billion-dollar companies, everyone scrapes. Whether it's to gain an edge or just to save time, scraping is the secret weapon of modern data workflows. APIs are great when they exist, but when there's no API, scraping is your backdoor. It's like the window is open even if the front door is locked. This is the most common question I get, and it's a fair one. Let's unpack the legal side of scraping without turning this into a law school lecture. Scraping is legal-ish. It's about being ethical, staying within the site's rules, and not being a jerk. Just because you can doesn't mean you should be smart, be nice. The best way for us to understand legal issues is to look at cases. Now, story time! This case rocked the scraping world. HeyQ was a small analytics company that scraped public LinkedIn profiles, stuff anyone could see without logging in. LinkedIn said, "Stop, that's ours," and tried to shut them down using the Computer Fraud and Abuse Act, it called CFAA. But the court said, hold on, this is public info. Scraping it isn't hacking. Big win for HiQ, right, Kinda? LinkedIn appealed. The case went up, came down, and eventually they settled out of court. The message: just because something is public doesn't mean it's drama free. So, yes, scraping public data isn't automatically illegal, but companies will still fight back. It's like poking a sleeping giant. You might be allowed to do it, but are you ready for the consequences? Before we start scraping like pros, let's lift the hood and see how the web actually works. What really happens when you type a URL and hit enter? Think of your browser as a chef turning raw HTML ingredients into a tasty website. Scraping says, nah, I'll eat the raw ingredients and skip the plate. If a website feels magical or changes after a few seconds, that's JavaScript, and we need Selenium to scrape that kind of magic. By the end of today, you'll be turning messy web pages into clean, structured data the right way. Let's go from curious clickers to confident scrapers. Now let's roll up our sleeves and get hands on. Static websites are the perfect place to start. All the data is already sitting there, just waiting to be scraped. Static pages are like open books. All the content is already there when the page loads. No JavaScript tricks, no waiting. Alright, let's start with the basics. What exactly is a static website? A static site is super straightforward. All the content is delivered right away when the page loads. There's no need to run JavaScript or interact with anything to reveal the data. What you see in the browser is exactly what's written in the HTML. This makes static sites perfect for scraping with tools like Requests and BeautifulSoup. You just download the HTML and all the data is already there. No extra steps, no rendering, no surprises. So if you're just getting started with web scraping, static sites are the best place to begin. They're like the low hanging fruit, easy to reach, and very rewarding. Scraping a static page is like brewing instant coffee. Add hot water's requests, stir as parsed, and enjoys extract. Let's walk through the basic workflow of scraping a static website. It's actually pretty simple. First, we send an HTTP GT request to the web page we want to scrape. This is like asking the website, "Hey, can I see your page?" Then, the server responds with the raw HTML of that page. This is just a big chunk of code. But don't worry, we're not reading it manually. Next, we use BeautifulSoup to parse that HTML. Think of this step as organizing the messy HTML into something more structured and easier to navigate. Then we locate the specific elements we want, like certain tags, classes, or IDs that contain the data we're after. Finally, we extract that data and save it, maybe to a CSV, a database, or just print it out for now. And honestly, scraping a static page is kind of like brewing instant coffee. Just add hot water, that's your requests. Give it a stir, that's BeautifulSoup doing the parsing, and then enjoy because the data is yours to extract. Boom! Here it is. Your first web scraping script in action. Let's break it down real quick. First, we import requests and BeautifulSoup, our two best friends for static scraping. Here bis4 means BeautifulSoup version 4. Then we set the URL of the site we want to scrape. In this case, we use Korea Times newspaper website. With requests getted, we fetch the HTML content of that page. We pass that HTML into BeautifulSoup, telling it to use the HTML parser to make sense of the raw text. Finally, we grab the title of the page using soup title text and print it out. It's like opening a book and checking the title on the cover before you dive into the contents. Simple, quick, and satisfying. And just like that, you've officially written your first scraping script. Before we write more code, we need to become HTML detectives. Time to inspect pages like pros and find the data hidden inside. Alright, it's time to become an HTML detective. When you look at a website, you're only seeing the final, styled result, but underneath it all, it's built from basic building blocks like h1, pa, div, and span tags. To find the data you want to scrape, you'll need to inspect the page's structure. And the best way to do that is using your browser's DevTools. Just right-click on the element and hit Inspect. Boom, you'll see the raw HTML. What should you look for? The tag names, like div or span, the class or ID attributes. These help you target specific elements. And the nesting hierarchy, because sometimes your data is inside several layers of tags. For example, in this snippet, we've got a product inside a div with class product, and nested inside that are the title and the price. So don't just scrape blindly. Dig in and explore the structure. The data's all there. You just have to know where to look. Find function is perfect when you're dealing with a simple, predictable layout, one product, one block, in and out with just a couple lines of code. CSS selectors are like laser pointers, super precise and super fast. Once you get the hang of them, your scraping code will be clean and elegant. .select .title grabs all elements with class title. .select one .price. .text gives you the first price element and extracts the text. And select div .product to span. targets the exact span inside the product div, super specific. In CSS selectors, the dot means class name. So dot price means any element with class price. Think of CSS selectors as laser pointers. They're super precise and make your scraping code clean, elegant, and fast. Once you get comfortable with them, you'll wonder how you ever scraped without aim. Alright, time to put all the pieces together. We've learned how to send requests, parse HTML, inspect the structure, and use CSS selectors. Now let's combine everything in a real, live scraping scenario. Imagine we're scraping an online store. Our goal, grab the product name, the price, and maybe even the rating, just like you would in an actual project. This is the moment where scraping goes from just a concept to something practical and powerful. Now you're scraping real product data from raw HTML. Let's walk through it step by step. In this example, we have a simple HTML block that represents a product. There's a div with the class product. Inside that, we have a heading tag with the class product-title, a span tag with the class price, and a div tag with the class rating. Using BeautifulSoup, we can extract each of these elements with CSS selectors. First, look at the first Python code line. This grabs the product title value as a text. Next code line, it gives us the price, for example, $19.99. And final code line gives us the product's rating, like 4 out of 5 stars. Once you've collected this data, you can save it to a CSV or Excel file, and boom, it's ready for analysis. This is real world scraping in action. You're pulling useful information from raw HTML, just like a data ninja. And when you scale this across hundreds of pages, the results can be incredibly powerful. Scraping isn't always smooth sailing. Let's talk about the most common things that can go wrong and how to avoid them like a pro. Websites change, servers push back. But don't worry, with patience and testing, your scraper can adapt and thrive. Bots get blocked, browsers don't. So act like one. Headers and delays make your scraper look more human and much less suspicious. Don't burn the bridges you walk on. The best scrapers are respectful, efficient, and get invited back instead of getting banned. I thought I was being clever, but the site thought I was a DDoS attack. A small time, sleep would have saved me a day of debugging and VPN hopping. Now we're leveling up. Some websites load data dynamically with JavaScript, and for those, requests just won't cut it. It's time to bring in the big guns, Selenium. Let's talk about why some pages don't play nice with BeautifulSoup and how Selenium solves that problem by acting like a real browser. Imagine ordering a burger and only getting the bun. The rest, patty, cheese, sauce, comes later through JavaScript. BeautifulSoup eats the bun. Selenium waits for the full meal. This happened to me on an e-commerce site. The page looked full of info, but my scraper just saw loading. Turns out, JavaScript was playing hide and seek. So we need Selenium, but what exactly is it? Let's break it down, and you'll see how cool it really is. Think of Selenium as your robot intern. It does the clicking, typing, and the waiting exactly how a real user would, but way faster and without ever getting bored. Time to get practical? Let's write our first Selenium script and see how it works step by step, no stress. This is Selenium 101. We launch Chrome, visit a page, grab the H1 title, and close it down. Boom! You just control the browser with Python. Installing the Chrome driver and installing the path is pretty tricky here, but don't worry, we'll walk you through it again in the lab. Sometimes when you visit a page, the content doesn't appear right away. That's because JavaScript is still loading the data behind the scenes, and that takes a little time. In those cases, if you try to scrape too soon, you might get nothing. That's where WebDriver Wait comes in. It tells Selenium to pause and wait until a specific element appears on the page. In the code example, we first import WebDriver Wait and expected conditions. Then, we create a wait object that gives the page up to 10 seconds. Finally, we use wait dot until to look for an element with the class name, price. Once that element is found, we grab its text and print it. The key idea here, don't rush Selenium. It's like waiting for a snack to drop from the vending machine. If you reach too early, you'll come up empty-handed. Give it a moment to breathe, and your scraper will work like a charm. Let me tell you, I used to rely on Sleep 5 everywhere in my scripts. And guess what? It still fails sometimes. Why? Because time.sleep just waits blindly. It doesn't check if the content has actually loaded. It's like setting an alarm but never checking if the pizza is actually done. On the other hand, WebDriver Wait is smart. It waits for a specific condition, like an element being present on the page. In the code, we use WebDriver Wait to wait up to 10 seconds, but it continues as soon as the element appears. No wasted time, no guessing. So the rule is wait for something, not just some time. Alright, now that you're waiting smart, let's find elements smart too. Selenium gives us different ways to locate elements on a page. Think of them as different tools in your toolbox. By .id, great when the element has a unique ID. By .class_name, when you're looking for a class. By .tag_name, like finding all the diffs or spans. By .xpath, very powerful, but can get long and messy. By .css_selector, readable and flexible, just like in BeautifulSoup. Use your browser's DevTools, just right, click and inspect to explore the HTML structure and figure out which selector works best. Selenium is like a treasure hunter, and these selectors, they're the map. Choose the one that gets you to the gold, fast, clean, and accurate. Let's look at real life scenarios where Selenium is not just helpful, it's essential. If the page interacts with you, you'll need to interact back. Whenever you see load more, content flickering in, or logging walls, that's Selenium's playground. This is no longer scraping. It's full on browser automation. Selenium is amazing, but it's also a bit bulky, like using a tank to check your email. Use it when you really need its firepower. Headless mode is like putting your scraper in stealth mode. No GUI, less memory, and it runs smoother, perfect for servers or background tasks. Alright, time to answer one of the biggest questions in web scraping. When should you use requests and BeautifulSoup, and when should you go with Selenium? Here's the breakdown. Use requests plus BeautifulSoup when the page is static, meaning all the content is already in the HTML. You want speed and scale? It's lightweight and fast. You're extracting data in bulk, like hundreds of pages. On the other hand, use Selenium when the page is dynamic and built with JavaScript. You need to click buttons, scroll, or interact with pop-ups. The site requires login or any kind of user interaction. Think of it like choosing between a sports bike and an armored vehicle. The sports bike, that's requests, it's fast, efficient, and great on open roads. Selenium, that's your armored vehicle. It's slower, but it can go anywhere, handle obstacles, and break through defenses. Choose the right tool for the right mission, and you'll scrape smarter, not harder. Until now, web scraping probably felt like a superpower. But what happens when the website pushes back? Let's learn how to stay sneaky, smart, and still get the data. The most common headache in scraping, getting blocked. Let's break down why it happens and how to avoid it like a digital ninja. So you're happily scraping away and suddenly, for Route 3 forbidden, what does it mean? It's basically the website saying, I see you and I don't like what you're doing. A 403 error is a clear sign that the site has detected your scraper and is blocking you. Why does it happen? You didn't send a user agent header. You made too many requests too fast. Or the site has bot detection algorithms in place. But don't worry, there are ways around it. You can add headers to look like a real browser. Introduce small delays between requests, and later we'll learn about rotating proxies to hide your identity. Think of 403 like the bouncer at a nightclub. If you walk up with no ID and act weird, you're not getting in. But if you show up looking like a regular guest and dressed the part, meaning you send proper headers, they'll probably let you through. Alright, let's talk about how to dress the part. By adding headers to your request. When your scraper talks to a website, it should pretend to be a browser. And real browsers always send headers, little bits of info about who they are. The most important one, the user agent. It tells the site what kind of browser and device you're using. In the example, we create a headers dictionary with a user agent that looks like Chrome on Windows and we pass it to request.get. You can also add other headers like accept language referrer, accept and connection. Think of headers as your scraper's disguise. Without them, your requests basically scream, I'm a bot, so let's give our script a fake mustache and blend in like a pro. Here's another key to staying under the radar when scraping: slow down. If you send requests too quickly, you'll start to look suspicious. No human clicks on 100 buttons per second, and your scraper shouldn't either. The fix? Add random delays between requests. In the code, we use Python's time and random modules to pause for a random time between 1 and 3 seconds. That tiny delay can make a huge difference in helping your scraper blend in. Think of scraping like fishing. You cast your line, wait a little, and then reel it in. Don't turn it into a water cannon, or you'll scare away all the fish. Now let's talk about proxies, your next line of defense. Sometimes it's not just your behavior the website doesn't like, it's you, or more specifically, your IP address. If you're scraping a lot of pages, sites might start blocking your IP. To get around this, you can use rotating proxies, basically fake identities from different locations. Proxies help you avoid rate limits and bans, distribute your traffic across multiple IPs, and simulate requests from different users. In the example code, we use a proxies dictionary with a fake proxy URL and pass it to requests.get. Think of it like a costume party. If you're wearing the same outfit and hitting the same buffet table over and over, people will notice. But if you switch disguises, you can move around freely without drawing attention. Alright? Time to level up. We're entering the realm of authentication and CAPTCHAs. This is where a lot of scrappers get stuck, but not you. Once you understand the tools and tactics, you can get past these barriers like a pro. First up, login required pages. Some content is locked behind a login screen, but there are two main ways to handle that. If it's a simple form-based login, you can use request.session to log in programmatically. Just send a POST request with your login data, and the session object will remember you. In the example code, we create a session, send a POST request to the login URL with credentials, and then use that same session to access the target page. If the login involves JavaScript or buttons and checkboxes, then you need Selenium to log in just like a human would. Think of sessions like a backstage pass. Once you're logged in, you can access the exclusive content, and Python holds the pass for you. Now let's talk about the dreaded CAPTCHA. CAPTCHA stands for Completely Automated Public Turing Test to tell computers and humans apart. In short, it's asking, are you really human? CAPTCHAs are specifically designed to stop bots, and unfortunately, they're really good at it. So what can we do? You've got a few options. Use a paid solving service like 2CAPTCHA or Anti-CAPTCHA, or use Selenium and solve it manually, which is not fun. Actually so difficult, sometimes some guy use machine learning for this problem. Or, honestly, just skip that site and find another source. Think of CAPTCHAs like laser tripwires in a spy movie. Yes, you can crawl through them, but sometimes it's better to take another route and save your energy. CAPTCHAs are evolving every day for real. You can find all kinds of open source tools out there trying to break them. It's like a constant battle. Someone builds a shield and someone else finds a way to break through it. So honestly, sometimes the smartest move is just to give up quickly and look for a different approach. Let's wrap up this section by talking about how to make your scraper not only work, but keep working ethically and reliably. Let's face it, scraping isn't perfect. Sometimes a page won't load, sometimes the server blocks you, and sometimes the whole script just crashes. That's totally normal. But the key is to handle those errors gracefully. In the example, we use a try and accept block. We send a request, and if something goes wrong, we catch the error and print it out. No crash, no chaos. You can also use logging to keep track of what happened. This helps you debug, retrieve failed pages, and improve your scraper over time. Remember, even the best scrapers hit bumps. But with smart error handling, your script won't just fail, it'll learn and recover. And finally, let's talk about scraping smart and respectfully. Before you scrape a site, check its robots.txt file. It tells you what's allowed and what's off limits. Use delays and realistic headers to avoid stressing the server. Be gentle. Don't hammer the site with hundreds of requests in seconds. And most importantly, never scrape private or sensitive data. Just because you can scrape something doesn't always mean you should. Think of scraping like being a respectful guest at someone's house. You take what's offered, you don't make a mess, and you always say thank you. That's how you get invited back, and that's how your scraper survives for the long haul. Nice work. You've reached the final chapter! Time to wrap up, answer questions, and share how you can go further with your new scraping skills. Let's do a rapid fire recap. If you're following along and nodding at this list, you're officially Web Scraper certified. If your brain feels pleasantly overloaded, that means you've leveled up. With these tools, you can scrape 90% of the public web. You're officially a data wrangler. You've learned how to scrape. Now let's look at how to turn that skill into real world projects and even cooler tools. The best way to improve is to build something you care about. Even a weird idea like track my pizza topping popularity is gold. Go have fun with it. One student built a scraper that tracks pizza topping popularity from blog posts. Was it useful? Maybe. Was it fun and effective practice? Absolutely. You now speak the secret language of the web. Use it well, automate boldly, scrape ethically, and don't forget to add a sleep function. Call once in a while.